Getting ready 1.6. So the first couple are just creating and solving equations from some story problems. So Virginia's painting service charges $10 per job and 20 cents per square foot. If Virginia earns $50 for painting one job, how many square feet did she paint at the job? So we've got square feet and we've also got money. Okay, those are our two variables, our unknowns. So how are they connected? Well, it's 20 cents per square foot and then $10 just to start the job. So we know that $50, okay, is going to equal our total cost there, how much she earned, is going to equal, well, that $10 for the job, and then to that we add 20 cents, right, for every square foot. So how many square feet did she do? That's what we need to know. So we times that number of square feet by the 20 cents, add the $10, and get that to equal 50. So there's an equation we can set up, and then to solve it, remember, we look at the variable and say what's been done to the variable. Well, first we'd multiply by 0.20, then you'd add 10. But we're solving for our variable, so we do the opposite in the backwards order. So instead of adding 10, we subtract 10 first, and then we divide by 0.20. So we start out by subtracting 10. That becomes 0. Adding 0 does nothing. And since we changed that right side, we also have to change the left side. So we do the same thing to the left side. So we get 0.20 square feet times S equals $40. So we did that step. Now we need to divide by 0.20. But since we're going to change that left side, we have to do it, or to the right side, we have to do it to the left side as well. So we get S equals, and then we go 40 divided by 0.20, which is 200. So what does that 200 mean? It's 200 square feet would cost $50. Number 2. Another problem. Renting the ice skating rink for Dane's birthday party costs $200 plus $4 per person. If the cost was $324, how many people were at Dane's birthday party? So, we know we're dealing with people, right? And cost again. So we're also told it's $200 plus $4 per person. So that $200 is the initial fee. Then you add to that for every person, you add $4. So we could go 4 times P. P we'll say is for people. Okay, now what is that going to be equal to? Well, the 324. So now once again we're just going to solve this. And you should notice it's a pretty similar process, isn't it? First we'd multiply B by 4, then we would add 200 if we knew how many people we were dealing with to figure out, how much the cost would be. But because now we're going backwards and solving it for the number of people, we first start out by subtracting 200, then dividing by 4. So subtract 200 from both sides. We're going to change the right side, so we've got to change the left side in a similar manner. Then we divide by 4. That cancels, leaving us with P equals 31. So there were 31 people there. Alright. So now let's just solve some equations. Same idea here. Okay, doing the same thing we just did. So I've got 4 times x minus 3. So if I'm thinking about x, first you'd times by 4, then subtract 3. But we're going backwards, right? That 4 would times by x, and we'd subtract 3. We've got to go backwards and do the opposite. So we're going to add 3, divide by 4. So I add 3 to both sides, because we're changing them now. When we change an equation on one side, we have to change it on the other side. 13 plus 3 is 16. Divide by 4 on both sides. We get x equals 4. Same idea for number 4. Okay? So what's happening to x? First you times by 6, then subtract 4. We're going backwards and doing the opposite, so we add 4, divide by 6. And that'll give us our answer. So I add 4 to both sides. Those cancel. We're left with 6x equals 26 plus 4 is 30. Divide by 6. and x gives us 5. Now we're going to take a look at inequalities. And inequalities are basically this, we treat them basically the same. There's one instance when we don't, okay? And that's when we multiply or divide by a negative number. Then we have to reverse the inequality. Other than that, you pretend there's an equal sign right here, and you just solve them that way. So x plus 15, we're just going to subtract 15 from both sides. That gives us x is less than 12 minus 15, negative 3. And remember, you read inequalities left to right. So when it's pointing that way, whether it's equal to or not, that would be less than or equal to. We'd read this way, when it's open to the left, as greater than or greater than and equal to. So number 7, what's happening to x here? Well, first we times by 2, then subtract 9. So we're going backwards in opposite order. We add 9, divide by 2. So add 9 to both sides. Those cancel. We're left with 2x is less than 12. Divide by 2. And we get x is less than 6. And if you want to check your answer, you just take your number, plug it in for x, then times by 2, subtract 9. Does it still work in the inequality? Yeah, that's what you're asking yourself. So, number 9, same idea. What's happening to x? We'd first times by 3, then subtract 5. So we are going opposite, add 5, divide by 3. So add 5 to both sides. We get 3x is greater than or equal to 15. Divide by 3. We get x is greater than or equal to 5. Okay, back up to number 6. Get rid of that minus 4 by adding 4 to both sides. You get x is greater than or equal to 17. Number 8, first we want to simplify, so we can distribute that 3x and get 3 times x is 3x minus 3 times 27 is 21. Then we want to get the x's on both sides, so we'd subtract 3x. We get negative 21 is greater than or equal to 3x minus 3x is actually 0x, which 0 times x is 0, so we get negative 7 is greater than or equal to negative 21. Okay, when this situation happens where you get rid of your x's, okay, you have to look at it. It basically tells you a few things. Either there's not going to be a solution, there's no value of x that will make this work, or it doesn't matter the solution, any value of x will make this work. So if I look at this one, is negative 7 greater than or equal to negative 21? That's true. So what that means is any number I plug into x will work. So it works in every single situation. They call that all rails. Alright, now let's solve and then graph on a number line. So first thing we need to do is solve for the variable. So in number 10 we'd add 2 to both sides, get x is less than or equal to 3. So now we got to think about what that means. Okay, so x is less than or equal to 3. So if I go to 3, put a dot here, can x be equal to that dot? Yes, it can, so I fill that dot in. Now it says x is less than. Remember, to the left is less, to the right is greater. So I would have to shade in all the way down the left side. Okay, 11, same idea. Add 8 to both sides, I get x is greater than negative 12. So I go at negative 12, and I say, okay, can x be equal to negative 12? It cannot. It does not have the equal to, so I have to leave it hollow. And it says x is greater, so then I shade to the right. Okay, number 12. 3x is less than or equal to 6, so we divide by 3, and we get x is less than or equal to 6. So that equal to means I fill in my circle, because it can be an answer, and x is less than, so I shade to the left. 13. We start out by subtracting 9 from both sides, so we get 18 is greater than or equal to 3x, divide by 3, and we get 6 is greater than or equal to x. So I go to 6, it's equal to, so I can draw in the circle, and 6 is greater, meaning x is less than, so I shade to the left. Number 14, we divide by negative 10. Now, here's one of those cases. We're dividing by a negative number. So we get x, I get negative 15, but because I divided by a negative, I have to switch my inequality. I have to reverse the sign. So I get x is less than negative 15 instead of x is greater than negative 15. So I go to negative 15. X is not equal to, so I make a hollow circle. X is less than, so I shade to the left. On number 15, I want to get rid of this 5, so I times by 5 on both sides. 5's cancel, we get x is greater than. Then 5 times 3 is 15. 10 times 1 is 10. 15 over 10 is like 3 over 2. So basically 1.5, and it's negative, so negative 1.5. So I go to negative 1.5, about right there. It's not equal to, so I make a hollow circle. X is bigger, it's greater, so I draw to the right. Okay, so with these inequalities, they can get more complex, but it's just gotta, you just follow it just like an equal sign. So here, we can add 5 to both sides to get x is greater than 2x plus 3 plus 5 is 8. Subtract the 2x. We get negative x is greater than 8. Then we divide by negative 1, and I get x and negative 8, but I've got to flip the inequality, so it's x is less than negative 8. Number 18, we multiply that 2 in, so I get 2 times x minus 2 times 3, which is 6, less than or equal to 3x minus 2. So I can, let's subtract the 2x from both sides. We get negative 6 is less than or equal to x minus 2. Add 2. We get negative 4 is less than or equal to x. Okay, and number 17, I want to get rid of that 12, so I times both sides by 12. Those cancel. I'm left with 3 times x minus 4 is less than or equal to 2 times 12 is 24x divided by 3. 24 divided by 3 would give us 8x. Then I distribute to get 3x minus 12 is less than or equal to 8x. Subtract the 3x from both sides. Get negative 12 is less than or equal to 5x. Divide by 5. And I get negative 12 fifths is less than or equal to x. Now, what is negative 12 fifths? I don't really care. That'll work for me. Alright, now these last ones, we're just graphing two equations on the same line. So in order to solve these ones, we just simply graph them. So the first equation is in slope-intercept form already. So let's see, let's make some axes that we can actually see well enough, close enough, right? So y-intercept of 5, we go up to 5, right about there. Slope of negative 1, so we make it negative 1 over 1. So down 1 to the right 1, down 1 to the right. So you can kind of see that pattern there. Or you can go backwards, up 1 and to the left 1. So there's our first graph. Now the second one isn't in slope-intercept form, but if you remember solving equations, it's all about manipulating them. Okay? So if I'm looking at this one, I've got negative x plus y equals 1. So I can add an x to both sides to get y by itself. So we get y equals x plus 1. So my y-intercept of 1, and then a slope of 1 over 1, so up 1 over 1, up 1 over 1. You should be able to see exactly where they're meeting. So be right there, which would be 1, 3. That would be where we meet, right? Except for some reason that's not looking right to me. Oh, it should be 2, 3, huh? Because my axis wasn't the best. It should be right there, 1, 2, 2, 3. That's what it is. Because if you're not sure, you plug it in. 2 for x. Does 2 plus 1 equal 3 for y? Yeah, it does. Look at this one. Okay, a negative x, so negative 2 plus 5, will that equal a 3? It will, so that works. Okay, now we do the next two. Now these both are in standard form, but we can turn them into slope-intercept form just as easily. Okay, so that first one, x plus 2y equals 8, so I'm basically solving for y. So if I want to, I can say, what are we doing to y? Times it by 2, add an x. So what do? Subtract x, divide by 2. So subtract x from both sides. I eliminate it on the left. 2y equals 8 and x can't be combined, so I just write negative x plus 8. Divide everything by 2. And we get y equals, that's like a negative 1/2 x plus 4. So that's a better x-axis. We go up to 4 on our y-intercept, and we're going down 1 to the right 2, 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 or up 1 and to the left 2. To make our first line. Now our second one, we treat the same way. So this time I'm going to have to subtract by 5x first, so minus 5x. That gives us 2y equals negative 5x plus 0, which is just 0, divide by 2. We get y equals negative 5/2 x. So we don't have a y-intercept, so we start at the origin, 0, 0. Y-intercept is 0. We're going to go down 5 and over 2. Down 5 and over 2. Or up 5 and over 2. Up 5 and over 2. So we should be able to see where they cross right there. Just that point should be what? Back 2, up 5. So negative 2, 5. Okay, there we go. Now the last one, same process. So start out by putting them into slope-intercept form, because that's the easiest to graph. So subtract 3x from both sides. You get 2y equals negative 3x plus 12. Divide by 2. You get y equals negative 3/2 x plus 6. So we get our x-axis here with our y-axis. Then I go up 6. Draw my point. Then we're going down 3 to the right 2, or up 3 to the left 2. 1, 2, 3, 1, 2. We're down 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. So there's our first line. Then our second, 4x minus y equals 5. So we subtract 4x from both sides, and we get negative y equals negative 4x plus 5. Divide by negative 1, get rid of that negative, and we get y equals positive 4x minus 5. So we go down to negative 5 on the y-axis, right there, and we're going up 4 to the right 1. Should see right there is where we're going to meet. Okay, so you draw your line. So our answer is right here, so it's over 1, 2, right? And up 1, 2, 3. So 2, 3 is our answer. Alright, and then to justify numerically, you can just plug it in. So for x, we'd plug in 2. For y, we'd plug in 3. And we're going to see if it works in both equations. So 2 for x 3 for y, and you can do this on all of them to double check. That's 6 plus 6. Does 6 plus 6 equal 12? Yep. First one checks off. 4 times 2 is 8. Does 8 minus 3 equal 5? It does. We just checked it numerically. Right there, guys.